Remember what we were doing? I know it's been a while since the weekend on Friday, but we had something like, 3x times, give me a number, 4. 7y plus, give me another number, 4. Okay, so write something like this. What would you do?
Let's do
This is that worksheet.
Okay, so what we've done is we just distributed, right? And we added exponents where we needed to, right? Okay. So what we're going to do now is we're going to multiply polynomials by polynomials, because this would be a polynomial times a monomial, because we just have one thing on the outside. In this case, we're going to do a polynomial times a polynomial. And first we're going to start off with two binomials, okay? So if I had a binomial like 2x plus 7 times 3x plus, we have number 4. Okay, this would be a binomial times a binomial, because binomial means 2, right? So I'm adding 2 things in this group, I'm adding 2 things in this group. Binomial times binomial, we're going to use something called FOIL. Okay, so this is what it stands for. FOIL stands for first, outer, inner, and last. First, outer, inner, last. Okay, so we're talking first. In our first group, 2x plus 7, what's our first term? 2x. In our second grouping, what's the first term? 3x. So what is first times first? Hold on, 6x squared. 6x squared. Okay, so that would be the f of 4. Okay, that's the first one. Now, outer, if I'm looking at groups as a whole, the outers will be on the outside, meaning I'm going to take 2x times 4, the outers. So what's 2x times 4?
Times 4, 8x.
So we're going to have us 8x. Okay, inners would be the ones on the inside. So we're going to take 7 times 3x. Gives us 21x. And then the last, well, if 2x and 3x were the first, what's the last?
7 and 4.
7 and 4. 7 times 4 gives us?
41.
41.
Oh.
Alright, so that would be first times first, and then outer time outer, inner time inner, and last time last.
That's weird.
Okay, but show it. Okay. I can't stop saying. Notice up here that we're taking everything times everything. I'm taking 2x times everything on the inside, and I'm taking 7 times everything on the inside. Okay? Just like when we do the distributive property, I take what's on the outside times everything on the inside. I'm still taking what's on the outside, 2x plus 7, times everything on the inside.
Oh, that's. I thought we already they used figuring out an addition, but I swear they had some problems like that on just like that review sheet, or not?
Nothing exactly like this, no. But we did probably do some of the distributive property.
Okay.
Or added. We did adding and subtracting, but we haven't been multiplying it. Okay, let's look at example 1 here. So it's 2 binomials, so I know that we have to do FOIL. And me, I am the worst speller in the world, you guys know that already. And I always have troubles with FOIL knowing if the O comes first or the I comes first. In other words, it doesn't really matter. As long as you take everything times everything, it doesn't matter what order you do them in. So usually with me, I go first times first, and then I do the inner, and then I do the outer, and then I do the last. It doesn't matter what order you put them, but that's usually what I do. Also, if you kind of look, it kind of looks like a weird guy. Notice here's like a nose, and here's a smile, and this is like his eyebrows, and then you have his eyes. So if you take the funny guy, that means that you've multiplied everything, and you know you've done it. Okay, so first times first.
Or like a pretzel.
Or a pretzel, sure.
It does look like.
Well, first times first. What's x times x?
X.
Okay, and then really we should probably do the outer because that's what FOIL. So outer times outer would be, and then inner would be,
3x.
and then last would be 6. All right, can I simplify this any?
Yes. It's gonna be 5x.
Good, put those together. More often than not, like 95% of the time when we're doing FOIL, you will be able to put those two middle terms together. Not always, but most of the time, you'll be able to do that. Always, always, always simplify. You can. Okay, let's try example 2. What are you going to do?
X times x
Gets us,
squared.
and what?
X times 7
Gets us,
7.
then,
negative 5
which would be
Minus 5 will make us 5. And then minus 35.
good. Can we simplify?
Just 2x.
Good. That kind of fun. I think. All right, let's see me. Tell me what you did.
2y times 6y.
Me.
12y squared.
Good.
And 2y times negative 7 is a negative 14.
Awesome. Why?
Y.
Good one.
And 3 times 6y, so 18y. And 3 times negative 7. Then you can put the two y's together.
Good.
No,
Yeah.
they're 14 1 plus 18
Maybe
Oh, I forgot to put the 1.
the line. So 12y squared and then
4y.
4y. You have to be very, very, very careful to watch your signs on these. But otherwise, I think they're pretty easy. It's kind of fun. Yep. Whenever you take a binomial times a binomial, you FOIL it. My algebra 2 kids always think it's funny when I say, no, you have to FOIL it, because they always think of SpongeBob. There's one of the episodes where he messes up something and he screams, soiled it, soiled it. So whenever that's what they think of. So.
There's this one fun man.
Whatever keeps you entertained. As long as you remember it, I don't care. Okay, let's do example 3. So the area of a trapezoid is 1/2 the height times or h times the sum of the bases b1 and b2. Write an expression for the area of a trapezoid. So first let's write out what they tell us. It says the area of a trapezoid is. So area, how do I write is with that equals 1/2 the height h times the sum of the bases. What's that?
5 times b plus 3x minus 7.
Okay, so base 1 plus base 2 times half the height. Okay, so in this case, and I think you're ahead of me, but I think you're right.
So the top and the bottom.
The top and the bottom. The bases are going to be, we get a little bit of geometry in here. The little arrows means parallel. I think you probably talked about parallel before, right? Parallel lines are like the railroad tracks that are very close to one another apart. So the two parallel sides would be our bases, and then our height, like we talked about with the triangle and everything, always has to be perpendicular between the two bases. So I could also put a right angle there. So my height is this dotted line. Okay, so we're going to plug this everything in to our next new formula. We're going to have half times the height. What's the height?
And then plus 2.
Okay, times base 1 plus base 2. So 3x minus 7 plus 2x plus 1. Okay, thinking order of operations. What are you going to do first?
Would you parentheses?
Okay, what do you mean?
Or then you can do 5x minus 6 inside the last parenthesis.
Yeah, I would put everything together over here. That's what I would do first. Make life easy. So you're right. 3x plus 2x gets us 5x.
minus 6.
and minus 6, because negative 7 plus 1 is negative 6. So I'm going to keep this out here, right? So all the same.
So don't you distribute your x plus 2 first, or the 1 first?
I would think that would have to be, that's me. You could distribute it if you want to. You have to be careful to only distribute it through once. And I think it's easy to just cover it up. And then what do we have?
Just 2 binomials.
We multiply two binomials when we use.
Oil it.
Boil it. Okay.
I'm making it so extra fun. You know my favorite episode? One of my favorite episodes is SpongeBob.
Good. Alright, so the first time first, now what?
Let's go on where the table is in SpongeBob and takes over.
No.
Okay, the first time first, go read it down.
X to the negative 6. Negative 6x.
Okay, then
2 to 5x. So 10x. And then 2 to negative 6.
so the 1/2 out there. We'll put it down.
Okay, simplify it. Make it 4.
And
Fix everything terms of that.
yeah, then I would distribute it out. I think it's easier to leave it to the end. Okay, so we just have 5/2 plus 2 minus 6. We should probably say units. Units. And on the front side. Alright, the distributive property, we can use that to multiply any two polynomials. It doesn't necessarily have to be two binomials. A lot of times it is. But when I'm working with any polynomials, we're always going to be really using the distributive property because the FOIL method is just another way to remind yourself to multiply everything times everything. So when I'm looking at this, notice I have a binomial times a trinomial. So we take everything in the trinomial times 4x and everything in the trinomial times 9. So I'm going to take everything times 4x first. Okay, so 4x times 2x squared gives us what?
8x cubed.
And then 4x times negative 5x gives us
20 negative 20x squared.
good. And 4x times 3?
12x.
12x. Okay, we're not done, so I've only distributed the 4x. So now we have to distribute through with the 9. Okay, so what's 9 times 2x squared?
18x squared.
Where do you have it? So big. Okay. What is 9 times negative 5x?
Negative 45x.
And 9 times 3? Okay, so we distributed everything. Now we can do some simplifying. So I would look for the biggest exponent first. What's our biggest exponent?
X cubed.
X cubed. Do you have any other x cubes to put this guy with? No. Alright, then we do squares.
Negative 2x squared.
2x squared, good. And then the x's, it's some split.
Negative 33.
I'm still just on my this variable. Okay, so on B we have a trinomial times a trinomial, so we have to distribute 3 times. So first I'm going to take everything times our y squared. So
6 squared before.
okay.
And then negative 3 y to the third cubed.
And then
Y squared.
get your negative sign to go with it there. So we have negative 12.
12y
Good. Then
negative 6y squared.
Positive.
Oh, plus 6y squared.
good. And then
Negative 2y.
and then you take everything times
Someone might know.
5. I know. You can go to the next line. So 5 times 6. What squared gives
Y
us?
squared.
All right. And then
Negative 15y, and then just plus.
all right. So we look for the biggest exponent. Which is the over. Can't put anything with it. And we have 2 3s. We got a negative 3 and a negative 12 gives us.
Negative 15.
Good. And then on 2 squares gives us.
7y squared.
We have 3.
We have 3 of them. So we would have what?
37.
37. Okay? How many more do we want?
Minus negative 17. I don't like the drawing problems because it takes so long to write them out, and it doesn't take that long to solve.
Doesn't take that long. Question about